a company specialising in physical pain relieving therapies. We would like to talk to you today a little bit about pain, various treatments, and the fantastic new range of innovative pain reducing products that we have today. Without further ado, and she's Technical Director of Boy Genius.
Hello, I'm going to talk to you today about pain. What happens when you are cutting a bagel and you immediately slice your finger with a knife? The size of the blood will drop your wheel and immediate a sharp pain. But what's actual pain? How do we sense it? Pain is an unpleasant feeling and emotional experience. It can be caused either by disease, an injury, or an emotional disruption. It gives us information about the location and the strength of the potentially tissue damaging stimulus. Marco McGaffrey gave a simple definition about pain. Whatever the patient says here, pain can be classified into three types: nonsensitive pain, neuropathic pain, and psychogenic. The differences between nonsensitive and neuropathic pain can be understood by different characteristic verbal descriptors. Examples for nonsensitive pain are aching pain and stabbing pain, while for neuropathic pain are burning pain and itching pain. Psychogenic pain is basically caused by emotional factors when no neuropathic or nonsensitive symptoms are identified. Headache and stomach pain can sometimes be psychogenic. Different theories were developed in the last 200 years. One of them was the nerve action potential developed by Raymond in 1848. He proposed that when body receptors are triggered by pain, electrical signals are sent through the spiral cord to the brain, which translates them into sensation. Nerve action potential propagates along a neuron and passes through several phases, as shown in this diagram. In this diagram, resting potential is the value when nothing is detected. Nerve action potential is triggered when self potential is up to its threshold. It peaks and finally shoots back downwards below the resting level until it reaches its initial state. More recent theories are intensity theory, compound action potential, and gate control theory. No single theory can explain all issues of pain, but a combination of ideas explains most aspects. Now I will pass you over to Mariam and Zaid to speak about methods of pain treatment.
As Mariam explained, pain is extremely complex. There are many factors affecting the way a patient is feeling, and all these play a key role in determining how much the patient is suffering. With a variety of products available on the market, it's often difficult to determine which product is best for the patient's needs.
Medication is obviously the most common form of pain relief. It comes in such forms as opiates and NSAIDs. Opiates include medicine like paracetamol and Vicodin, as the last Dr. House has taken. And the benefits are it's a good sedative and reduces the mental perception of pain. It, however, may cause dependency and addiction and may lead to people becoming homeless. NSAIDs like aspirin and ibuprofen use anti-inflammatory properties to reduce pain. The benefits are it's a strong analgesic. However, it does cause your blood to thin, and in the case of an injury, it can increase the likelihood of bleeding to death. Hypnosis and cognitive behavior therapy is also a promising form of therapy for pain relief. There is a strong relationship between pain and emotions. The theory is if you can control your emotions, you can control the pain through mental training. There is growing scientific evidence for its effectiveness. The National Institute of Health has recommended the incorporation of CBT into the treatment of chronic pain. There are no side effects, and it has a genuine positive effect on the person's mood. However, you have to be careful of people who have pre-existing psychiatric issues.
There are also many alternative therapies available on the market today. One that we considered for our project was TENS, which stands for transcutaneous electrical nerve stimulation. TENS works by putting electrodes on the affecting area and claims to work by sending electrical impulses through the skin, resulting in nerve excitation. It claims to work by stimulating non-pain nerve fibers which send signals to the brain, blocking other pain-carrying signals. At first, seemingly promising, TENS has strong evidence disproving its effectiveness in pain relief. Sadly, this is the case for many of the other therapies available on the market, such as acupuncture, Max, our head of safety and ethics.
At UCL, we focus on heat and cold therapy and mechanical techniques, as they have been proven to be the most effective. Heat and cold therapy works by manipulating the temperature of the chosen area. Heat therapy relaxes the blood vessels, allowing for an increase of blood flow to the chosen area. Cold therapy does the opposite, constricting the blood vessels, therefore decreasing the blood flow. The scientific reasoning for its analgesic effects are attributed to a variety of mechanisms, including the gate theory. However, the precise mechanism is still not known. While it is still under debate how this therapy works, the scientific community unanimously agrees upon the analgesic effectiveness of this therapy. Mechanical techniques, like massage chairs and shiatsu massage, manipulate soft tissue, but also can claim to affect the blood circulation and the nervous system. Although you may think analgesic effects can be attributed to placebo effect, research in the 80s found a 68% success rate at reducing pain through mechanical techniques, compared to placebos, which only had a 38% success rate. Both these therapies, in recent research, have been proven to be the best form of alternative therapy for pain relief. I will now hand you over to Matt, our safety officer, to talk about the ethics of our experiment.
We focus importance into the ethical issues of manufacturing the device, especially one involving heat therapy and mechanical techniques. The temperature and massage and their relation to pain are very subjective. We felt that human experimentation would be necessary. Therefore, we had to consider ethical issues of producing the device and testing the product effectively. When researching ethics, I found that Professor from Brighton summed up concisely what we needed to consider. Professor Stu Eckstein made 3 suggestions. 1. Student work to include sufficient literature-based research in order to acquire adequate knowledge and first develop a prototype device. 2. Students should be aware of ethical standards during their research, the most important of which are informed consent, risk control, and proper technique. 3. The aim of student projects should not be to generate new knowledge, but rather enhance the student's already existing knowledge. We concluded that testing the product on ourselves would be allowed, as rigorous safety checks and risk assessments were completed throughout. Now, two of our product developers, Josh and Abby, are going to help me thoroughly discuss lovely vests I'm wearing. According to NHS statistics, approximately 8 out of 10 adults will suffer from back pain at some point in their lives. Approximately 40 million people in the UK alone. This pain is most commonly associated with the lower back areas and neck pain. This is why we at UCL have developed a deluxe inner heat vest.
The vest has 3 ergonomically designed heat pads, one at the top of each shoulder and one in the small of the back. These were all developed using the inner heat technology.
Each heat pad is comprised of a composite structure of high-density foam for strength and flexibility of the pad, while of the low-density foam to dissipate heat with wire. An aluminum shielding was added to reflect the heat back onto the desired area of the back and to stop it from radiating out the back of the pad, onto which are high resistivity polytetrafluoroethylene coated nitrile was thrown onto for another layer of low density foam, all encased in a thermal fabric casing.
This was developed using preliminary tests of resistive wire, which found an equilibrium between length of the wire, the heat distribution, and power delivered by the battery. 0.2 mm PTFE coated micron wire was found to be the most suitable, giving the perfect combination of power and temperature.
The wire was significantly mechanically robust, and the temperatures radiated from the wire were suitable for the use of a 9-volt battery. 9 volts applied across a 40 cm section of this wire drives a current of 0.69 ampere.
Now, a typical 9-volt lithium battery provides 1200 milliamp hours. 2 of these will power our prototype vest for just under an hour and 45 minutes.
The The detailed computational heat equation model, as will be explained by our CEO James later on, enabled the calculation of the length of this wire so to achieve the optimum exterior temperature of 43 degrees Celsius.
At above 43 degrees, TRPV1 heat receptors acknowledge pain. But Dr. Brian King of the UCL Physiology Department has proved that heating the body to above 40 degrees can provide pain relief. The inference of this is that a device that heat the body to within 40 to 43 degrees theoretically provide pain relief. It is therefore very important to focus on balance between heating the body and preventing thermal injury.
Each shoulder pad contains a 20 centimetre length of night chrome wire, which is connected in series using the standard wire, sewn down the seam of the vest to the battery in the left pocket here. The back pad contains 36 centimetres of night chrome wire, connected in a similar way to the right-hand side. The relatively shorter length in the back pad is to account for the fact that the back is a slightly warmer part of the body, and therefore the back pad will provide a slightly warmer heat.
Electrical safety was considered, as if the installation was to fail, the wire could touch the skin running a current through the body. However, as the vest is powered by two 9-volt batteries, the possible shocks were tiny, although new clinics do advise patients with pacemakers not to use the device.
The inner heat technology has been developed further so to create a modern alternative for the hot water bottle. The inner heat thermal pad, or iPad, is a chargeable, lightweight heat pad designed for aches and pains on the go.
Compared to the traditional hot water bottle, the thermal pad does not tear, scald or sag, and the associated fire hazards are not less than with weak heat packs that are available on the market currently.
Here we have a selection